All right. Hi, guys. I know it's late. I'm going to go through these. I'm sure all you guys are tired. I'm tired too, but here we go. So, one of the things that I totally forgot to put in here is that these are regular. This guy is a regular octagon. So, when we go through this for the regular one, you have to identify the shape. There are 1, 2, 3, 4, 5, 6 sides. That makes this guy a hexagon. When you find the sum of the interior angles, there's a formula for it. It is here so you guys can see more work. Okay. When you find the sum of the interior angles, the formula for that is 180 times n minus 2, where n is your number of sides. So when you do this, you got to count the sides first. There are 6, so it's 180 times 6 minus 2. I'm going to go over here. 180 times 6 minus 2, which is just 180 times 4. Which is 0, 32, 720. So total, the sum, right? Always make sure you know what they're looking for. The sum is 720. Now they want the value of 1. I should have said 1 interior angle. 1 interior angle. So you're just going to take your total and divide it by the number of sides. So it's going to be 6 divided by 720. 720 divided by 6 goes in there 1 time. 6 goes in there 2 times. Basic. The value of 1 interior angle is 120 degrees. Can't see the paper. Can you guys see it now? I'm seeing it on my side, so can you see it? Is there a review sheet there? It's showing on my end. Let me see. Can you see? I'm gonna wait a second, see if you guys can see this. Not so much. Let me zoom in. Is that better if I zoom in that way? Let's see, is that better? If you guys can't see it, you gotta let me know, because otherwise there's no point. Otherwise I'm just talking to myself. All right. Gonna do number 2. You can keep zooming in. You should have the paper in front of you so you can follow along. Let's see. How's that? All right. So for number 2, we want to find the interior angle sum of an octagon. And anytime you want the sum, remember that's all of them. That's the total. So you're going to use the formula 180 times n minus 2 to get that. An octagon, you need to know, has 8 sides. So it's going to be 180 times 6. Plug in 8 right here. And then you get that. So 180 times 6 is going to give me 1080. So the interior angle sum of a regular octagon is 1080. So let me put that up here. Let me pick a different color. So this guy right here is 1080. To find 1 interior angle, you just divide your total. Zoom out a little bit. Divide your total by the number of sides. So 1 interior angle is 8 into 1080. Goes 1 time. Just divide. That goes 3 times 24, 40, 135. So the measure of one interior angle is 135 degrees. Find the measure of one exterior angle. One exterior angle. All right, so your one interior angle and your one exterior angle are always supplementary. So one interior and one exterior are supplementary. You know the one interior is 135, so your one exterior is 180 minus 135, which is going to get you 45. So your one exterior angle is 45 degrees. And the sum, this one's kind of fun, the sum of all exterior angles, this is, no one's trying to trick you. No matter what shape you have, as long as it's regular, the sum of the exterior angles is always going to be 360 degrees. So if it asks you for an octagon, if it asks you for a pentagon, if it asks you for a dodecagon or a 100gon or a 500gon, it doesn't matter. It's always going to be 360 degrees for the sum, the total. Okay, to find one, you only need to do 360 divided by however many sides you have. All right, this guy down here. 4 sides, quadrilateral. All quadrilaterals have a total of 360 degrees. I'm going to add up all of these and set it equal to 360 degrees. So this wants me to find the value of x and then find the measure of this guy right here. I know, I'm supposed to be sleeping right now too. I'm tired. I feel you guys. But you know what? We're going to grind through for a little bit and maybe you can dream about math. All right, add all these guys up, set them equal to 360. This guy right here, don't forget, he's 90. So we're going to have 90 plus 84 plus 2x plus 118 plus 2x plus 68 all equals 360 degrees. Let me focus that. I feel like my writing's a little blurry. There we go. Combine like terms. 2x, 2x. That's 4x. Combine your other like terms. You've got, grab another pen. You've got 90, 84, 118, 68. Okay, let's add up all those guys. So let's go 90 plus 84. It's me 174. Okay, I got those guys. I'm going to add 118 to that, which gets me 292. I'm going to add 68 to that, and I'm going to get 360. So 4x plus 360 equals 360. Subtract 360 from both sides. 4x equals 0. Divide both sides by 4. X equals 0. So you found x. X is equal to 0. Now it wants this angle right here. Plug it back in. That is 2 times 0 plus 118. 0 plus 118. So the measure of y is 118. That one came out a little funny. All right, for this one, identify the shape, the most specific. This is a huge part of your test, being able to identify which one it is. Your only logical choice, because it only marks that the sides are parallel. Remember that these little, they're called caret marks, but that indicates parallel. Right? And it doesn't tell you anything about the inside angles. It doesn't tell you anything about the diagonals. So your best choice for this is a parallelogram. That's your best choice, okay? For a parallelogram, opposite angles are equal. Same side angles are supplementary. So again, opposite angles are equal. Same side are supplementary. So let's set these equal to 180. They're on the same side. We have 30x plus 150x equals 180. You have 180x equals 180. Divide both sides by 180. X is equal to 1. What's the difference between, oh, okay. So the reason I have 2 on this side and 1 on this side, it's just kind of the same reason as making your hash marks, saying that these 2 lines are parallel and these 2 lines are parallel. I'm just differentiating what sets of lines are parallel. So for these, I mark them with 1 so that you know that these are the 2 lines that are parallel and not this one and this one. It's kind of like when you guys do your triangle congruency and you mark congruency with 1 for the ones that are congruent, and the second one is 2. So this is just to show that these 2 lines are parallel, these 2 lines are parallel. I have 2 sets of parallel lines. All right, this guy only wanted you to solve for x, no problem. Proofs. All right, proofs are a big part of your test. I don't want you guys freaking out on the proofs. They're not as hard as you guys think they are. For squares with, what's that? So for squares, we use that. You can, if you're trying to show that they're parallel, or you use the other tick marks to show that they're congruent. That means parallel. Let me show you guys. I think I know what you're asking. So like if you have a square and I mark this like that, this means that all my sides are congruent. Okay, if I mark it like this, that's showing that this side and this side are congruent, and this side and this side are congruent, not necessarily all 4 sides. All 4 sides are the same, that's why I have the same tick mark. If you wanted to show that these lines are parallel, you could put that in to make sure you know that they're parallel. All right, proofs. Always get the given, okay? Given is literally copying. You always start here. So start with your given, write it down, and get, your basic point, half a point, whatever it is. Take the easy points where you can find them. You always want to end with that. So again, take the easy points where you can find them. So as I go through, I'm going to mark this. Angle G is congruent to angle I. Angle G is congruent to angle I. I'm going to mark it as I go along. Angle I and angle G are congruent. You're always going to want to mark your figure. It'll make it way easier for you. And the reason I know that, it's given. No brainer. Literally copy what's there. Okay? Copy all of it. FH bisects angle GFI. FH bisects GFI. So here's FH. Here's angle GFI. GFI is this huge angle right here. Now here's where you have to know a little bit of vocabulary. You need to know what the word bisect means. All right, bisect means to cut in half. And in this case, it's cutting this angle in half. Sometimes it can cut a side in half, sometimes it can cut an angle in half. But in this case, FH, this line segment, is cutting this angle in half. And if it's cutting this angle in half, then this guy and this guy are congruent. Here's the whole angle. The whole angle GFI is this whole thing. This guy coming through is cutting it in 2 equal pieces. All right, because of that, there we go, that's given. I'm going to say that angle GFH, I'm going to say that this angle right here, GFH, this guy right here, is congruent to angle IFH. Okay, and how do I know that they're congruent? Because that's what the definition is of bisector. How do we know that G and I are congruent? Because it was given. It's right here, given. Angle G is congruent to angle I. All right, We know that this angle is congruent to this angle because of the definition of bisect. Okay, because they told us that this bisects it. So you can put definition of bisector, definition of angle bisector. So there you go. All right, so right now I've got an angle. Remember, when you're looking to prove things, your choices are going to be side, 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 angle, angle, side, or hypotenuse leg. And remember, this guy is only good for right triangles. All right, this guy's automatically out. I don't have a right triangle here. There's nothing on this diagram that indicates right triangle. So that guy's out for this. I already have two angles. So let's figure out how I can get a side somewhere. And either I'm going to go angle, side, or I'm going to try to find a side in the middle. So if I want a side in the middle, I got to try and find this guy and this guy. There's no markings or any way I can figure that out. The easiest, I'll show you HL on the next one. The easiest thing to do is to look at this guy right here, FH. So look at your guy right here, FH. I'm going to mark him in green right here. This guy right here, if you see, FH is shared by both triangles. So I'm going to write line segment FH is congruent to itself. It's the same line twice. And I can say that because it's reflexive. That's reflexive. All right, so it's congruent to himself. I'm going to mark that with the congruent. And right now I've got angle, side, angle, side. So I'm going to say at the very end, triangle GFH is congruent to triangle IFH because of angle, side. Again, easy points. Your prove always is at the end. Your given is always at the top. Take the easy points where you can get them. All right, this one. All right, another example. So for this one I'm going to show you. We're going to prove it by hypotenuse leg. I'll show you how we do that. I don't think hypotenuse leg is actually going to be on this exam. Sorry, this thing's getting crooked. Try it that way. All right, I don't think hypotenuse leg's on the exam. I'm going to solve this for you guys or prove it for you guys just so you guys can see what it would look like. And it will definitely be on a later exam. We're going to get into a lot of right triangles later on. So, all right. Always start with the given, okay? As you start writing your given, mark up your figure. So first up, angle W and angle Y are right angles. Why do I know that? It's given. There's my reason. And I'm going to mark them. Angle W and angle Y are right angles. Okay, hold on. Let me go back. We already used GHF is equal to IHF. Let me see. In order to explain, hold on. But we already used GHF is equal to IHF. No, we didn't use. You mean up here and up here? I think, is that what you're talking about? Like, I'm trying to figure out, Natalie, what you're talking about. This is what we're trying to prove. We're saying that given these two things in this figure, how do I get to here? How do I actually prove that these guys are congruent? And the way I prove it is because of angle, side. Let me do this one, see if it makes a little bit more sense when we go through the proving part of it and see how you feel about it, okay? And then if it doesn't make sense, I have plenty of proofs to do, okay? So let's try this. All right, so angle W and angle Y are right angles. I marked it, that's given. X is the midpoint of WY. X is the midpoint of WY. All right, this is the midpoint. All right, again, vocabulary you need to know. All right, the reason we know that, it's given. We'll come back to that one. And then I have Vx is congruent to Zx. Vx is congruent to Zx. And why do I know that? Because that's given too. So I've marked this. It was given. I marked my right angles. It's given. Here's what you need to do. Anytime they're going to give you a right angle, you automatically need to declare that it's a right triangle. All right? That'll give you the option of using hypotenuse leg as an answer. So I'm going to say that triangle, however you want to name your two triangles, I'm just going to name it XWV. Again, it doesn't matter how you name it, is XWV and triangle XYZ are right triangles. Okay. How do I know they're right triangles? Because they have a right angle. That's the definition of a right triangle, right? It has a right angle. So I'm going to say that, zoom out of that for a second. I'm going to say that I know these are right triangles because of the definition of a right triangle. The definition of a right triangle is there's one right angle. That was given to me. So I'm going to declare right now that with my right angle, I have two right triangles. Can we cheat and using VWX as reflexive? No. Reflexive is the same line you're using twice. You're not using the same line twice. Reflexive is two triangles sharing the same line. They're not sharing anything. All right. So I'm going to say this is a right triangle. This is a right triangle. All right. Here's where the midpoint part comes in. So it has to share a line, not a point. Got it. Correct. All right. So here we go. It's the midpoint. Midpoint means the middle. If you're exactly in the middle, then this part and this part are the same. So this guy and this guy are the same. And I'm going to write it here. Line segment WX is congruent to line segment YX because of the definition of midpoint. Okay, they told me this is the midpoint. These two have to be equal. All right, so here's where I'm going to prove my triangle congruency right now. It is not angle side side. Remember, there's no such thing as angle side side. No profanity on your exam. No angle side side. When you're dealing with the right triangle, you can use the hypotenuse. Here's my hypotenuse. It's the guy across from the right angle and a leg. So my very last one is going to be triangle VWX is congruent to triangle ZYX because of hypotenuse leg. It's not SAS. It's not side angle side. In order for it to be side angle side, it would need to be side angle side. Your angle would need to be in the middle, or it could be this one, side angle side. But this guy's out here, so you kind of just go in order. This is side, side, angle, angle, side, side. You can't have that, okay? In order for it to be side, angle, side, you would need the angle in the middle. Side, angle, this side. Or side, it doesn't matter where you start. It doesn't matter where you start, okay? If I started here, angle, side, side. If I started here, side, side, angle, that doesn't make any sense either. Can we do another one like number 5? Yeah, I'll get you guys more proofs. Let me get through the last couple of these, and then I'll bring out a couple more proofs that are that are more like this and not the hypotenuse leg. No problem. All right. This guy right here is on your test. All right. Questions like this are on your test. And I think this is where we have the biggest amount of problems because it has to do with what happens on the inside of these, okay? You need to draw a rhombus. I'm going to draw it right here. And label it, it can't be SAA, angle, angle, side. Yeah, it could definitely be angle, angle, side, but you don't have two angles. The only angle, yeah, angle, angle, side is a completely appropriate answer, but you only have one angle. You don't know what this angle is. You don't know what this angle is. So you can't use angle, angle, side. You have to go with what's given. like things that you can prove. They don't talk about this angle at all. They don't talk about this angle at all. Can you rewrite it like that? No. No, because that's saying angle, angle, side, which would be angle, angle, side like that. You don't know anything about these other angles. You don't have two angles to pick from. The only angle you know about is your right. Okay, let's go with your rhombus. Remember, on your rhombus, all your sides are equal. They want you to draw a rhombus, label A, B, C, D with diagonals intersecting at point E. Here's the important thing when you label. It doesn't matter where you start, okay? I can go A, B, C, D, A, B, C, D. What matters is you can't just go A, B, C, D. You can't jump around. You just go in a clockwise motion, right? And it wants my diagonals. There are my two diagonals to intersect at point E. It tells me that AE is 6. And it wants me to find AC. You can't do these questions unless you understand the properties of the rhombus, the square, the rectangle, the parallelogram. Those are the ones you need to know. You need to know those four the most. All right, I know that in a rhombus, that the diagonals bisect each other. Okay, it's actually a perpendicular bisector. So again, they bisect each other. Bisect is my buzzword. Bisect means cut in half. So I know that this guy and this guy are congruent. I know that this guy right here and this guy right here are congruent. If this is 6, then this guy right here is 6. So to find the measure of AC, I know AE is 6. I know this guy right here is 6. I add them together, I get 12. For this kind of stuff, you got to memorize it. You have to know what the inside does. All right. Find the measure of AED. AED. All right. AED. AED is this guy right here. All right. You also need to know that a rhombus, the diagonals create perpendicular bisectors. They create perpendicular bisectors. So perpendicular, there's your key word. Perpendicular is 90-degree angles. All right, here's a 90-degree angle. This guy's a 90-degree angle. This guy's a 90-degree angle. This guy's a 90-degree angle. All these guys are 90-degree angles. So AED is a 90-degree angle. Inside of a rhombus, perpendicular bisectors for the diagonals, you get a 90-degree angle up here.